Alright, boys and girls, welcome back to the drive-thru. Special shout out to True and Mr. Ray. What a great little discussion they just had. I enjoyed being a little part of it. Now we're adding two more constraints to our pet situation. We've got to feed these things, and we've got to pamper and walk these things, okay? And Carlos and Clarita can't spend every minute of their day working. No one wants to do that. So there are additional constraints that we have to work in. On this page, we're going to work in the equations, and then we'll go to the next page and we'll graph them. So let's look at the feeding constraints. The cats will require 6 minutes twice a day to feed and clean their little box. That's 12 minutes per cat. So that's going to be 12x. Okay? The dogs require 10 minutes twice a day. You got to feed them and you got to walk them. So that's 20 minutes per dog. And let's see. Carlos can spend no more than 8 hours a day in the morning and the afternoon feeding and pampering these. Now there's a problem with that equation. I want you to look at it and spot the problem. 12 is in minutes, 10 is in minutes, 8 is in hours, and so that's not going to add up. So 8 hours is 8 times 60 minutes. That's 480 minutes. So that's our feeding constraint. And let me just come over here real quick and write that down. 12x plus 20y is less than or equal to 480. Okay? Now, we also have some pampering constraints. So you got to brush them and pet them and treat them right. 16 minutes per day per cat and 20 minutes per day per dog. And that also is an 8-hour max. Okay, so let's think about, before we get our graph up, let's think about what size graph we need. And to do that, let's figure out our intercepts. Okay? So if you put in a 0 for x, you get 20y equals 480. 480 divided by 20, I believe, is 24. So if we spend 0 minutes on cats, we will have 24 minutes to spend on dogs. If we spend 0 minutes on dogs, then you'll have 480 divided by 12, and that is 40 cats. We could do 40 cats or 24 dogs or somewhere in between. Here, again, you get a 24. But 480 divided by 16 is just 30, so we got some different constraints to deal with. So we're going to need to go as far as 40 on the x-axis and as high as 24. So let me pull up Desmos. And we're going to select a range that looks like this. As high as 24 and as far as 40. And we're going to paste that twice over here because they said to graph it on 2 separate axes. Whoops. So one here and one there. All right. So now it's very easy to plot these. We do still have to shade them. We'll make this a blue line. So it goes from 0, 24 to 40, 0, and it is a filled-in line. Okay? This one goes from 0, 24 to 30, 0. Oh, let me undo that. Let's make that a red line. 0, 24 to 30, 0. And you might be thinking, well, that 24 looks too high. Well, deal with it. Now, that's not the answer. Because, look, can we have 10 dogs and 10 cats? Yeah, that works. Can we have negative 10 dogs? No, can't have any negative dogs. So anything under that line will work. And anything under this line will work for the pampering. And these are our regions of feasibility, our possible regions. These are where we can possibly take that many cats and dogs. Let's do a couple homework questions, and you guys will be on your way, okay? Write these equations so that they are in standard form. So we want to get all the y's and x's on one side. So we're going to subtract 7x from both sides. That leaves you with negative 7x plus y is negative 3. We want a to be positive. So let's divide everything by negative 1, and you get 7x minus 1y equals positive 3. Okay? We'll skip 5 and do number 6. 1y equals negative 4x minus 11. Add 4x to both sides, and you get 4x plus 1y equals negative 11. A is positive, and that is standard form. Have a great day. Boom!